yet to another lesson of mole concept. Okay, now when we talk about mole concept, we have been breaking down into different lessons. Now here we are going to look at molarity. Okay, now here we look at, basically you have water, probably water in a container, then you have particles of maybe sodium chloride. Now when these ones are dissolved into water, you form sodium chloride solution. Okay, now this solution has volume, let's say 250 centimeters cubed. That is the volume. Now, so this solution can be has its own molarity, and it can always be determined. Now, what do we mean by molarity? Molarity simply is the number of moles of a substance contained in 1 liter. So it means that you get the number of moles of sodium hydroxide in 250, then you find out how many will be in 1 liter. 1 liter is equivalent to 1000 centimeters cubed. Okay, and if you get the number of moles of the substance in 1 liter, then it means that solution is called a standard solution. Standard solution is a solution of known concentration. Then a molar solution is a solution that contains 1 mole of a substance per liter. Call it a molar solution. Okay, I hope molarity is kind of understood. You say to get molarity, you must have moles in a volume which is equivalent to 1000 centimeters cubed. So we shall be playing around with different volumes, then we relate it to 1000, like that. Okay, let us look at this example. We have 2 grams of sodium hydroxide was dissolved in water to make 200 centimeters cubed of solution. Calculate the molarity of the solution. Let's say this one this time is 200, and this is now sodium hydroxide. Okay, so if this is sodium hydroxide, they are saying that now these are 2 grams. When you have 2 grams of sodium hydroxide dissolved in water 200 centimeters cubed, then you get a solution. Find the molarity. Okay, step 1. In order to get the molarity, remember these are mass, and what have we said? Molarity, we talk about number of moles. So convert this mass into moles. This is what we do first. 1 mole of sodium hydroxide weighs, this is our concept 1, concept 2, which we have been talking about earlier. 1 mole of sodium hydroxide weighs 40 grams. Because sodium is 23, oxygen is 16, hydrogen is 1. Then we interchange. 40 grams of sodium hydroxide contain 1 mole. What about 2 grams of sodium hydroxide will contain 2 times 1 over 40, and we get 0.05 moles. So those are moles in 200 centimeters cubed. Now they say, what is the molarity? Change those moles from 200 to 1000. So we shall say 200 centimeters cubed of sodium hydroxide contain 0.05. What about 1000 centimeters cubed of sodium hydroxide will contain, cross multiply, 1000 times this over that, and we get 0.25 molar. So that is the molarity of that solution. I think you have got the molarity. Now we are going to look at another part of mole concept, and this is called volumetric analysis. Now volumetric analysis will deal with reactions and volumes. Like I can have sodium hydroxide maybe 25 centimeters cubed in a container. Then I react it with HCl. Maybe it is, for complete reaction, I get 20 centimeters cubed. Then it means that one of these substances must be of known concentration such that I can be able to get the concentration of the other. So we call it volumetric analysis. We deal with the volumes of different substances. Now, determining molarity of concentrations, volumetric analysis can be used to determine molarity of different substances, the concentration in grams per liter, percentage purity, value of N, then value of N, where N is the rate of oxidation, and maybe the relative atomic mass. We can look at one example here. Other examples we shall look at them in our next episodes. Example: we have 25 centimeters cubed of 0.1 molar sodium hydroxide. Required 25 of sodium hydroxide, required 12.5 centimeters cubed of sulfuric acid for complete reaction. Wow! So here is sodium hydroxide. This time, instead of HCl, we have sulfuric acid. Now they are saying you have now volumes, different substances. Now when they react, they, on complete neutralization, if I use 25 of sodium hydroxide, for sulfuric acid, it requires 12.5 centimeters cubed. Then they ask you what is the molarity. Now, let us look at this question. We have 25 centimeters cubed of sodium hydroxide, required 12.0 sulfuric acid for complete neutralization. It means when you have an equation between sulfuric acid and sodium hydroxide, or when you have a reaction between sodium hydroxide and sulfuric acid, 25 centimeters cubed of sodium hydroxide required only 12.5. So it implies that if you had two substances, as we saw earlier, that sodium hydroxide maybe was 25, and then the other substance, sulfuric acid, is 12. Okay, so when you combine the two for complete neutralization, this 25 required that. So we are going to compare the volumes. So when you are given such a question, you start from a point of known concentration. Now in this case we have 0.1 molar sodium hydroxide. Okay, this one required 12. Now this one means you have 0.1 molar. So 0.1 molar means 1000 centimeters cubed of sodium hydroxide contain 0.1 moles. That's what it means. So in other words, so you must know, you must have at least the starting point of such statement. Now when we want molarity of the other substance, we start from there. Then here we say identify the substance of known concentration. In this case it is sodium hydroxide, and we have said the concentration of sodium hydroxide is 0.1 molar. That means that 1000 centimeters cubed of sodium hydroxide contains 0.1 moles. Therefore, in our statement we shall say 1000 centimeters cubed of sodium hydroxide contains 0.1 moles. But remember, we want, because 25 reacted with 12, so we want to move away from the 1000 and we go to 25 because it is the volume that reacted. Therefore, the moles we shall get are the ones that reacted. So what about in 25? Will contain, then we cross multiply this times that over this times that over that, and we say 0.1 times 25 over 1000, and we get the answer. Now we have got the number of moles of sodium hydroxide that reacted. Then we use our equation to get the moles of the unknown, the substance whose concentration is not known. So we write the equation. Sodium hydroxide reacts with sulfuric acid to form sodium sulfate and water. Now, from this we say 2 moles from our equation, 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. 2 moles react with 1 mole of sulfuric acid. What about this one? Remember, in our question they said 25 required exactly 12. What about these ones which are in 25? 2.2, 2.5 times 10 power 20 power 3 moles of sodium hydroxide will react with. Now these ones are the moles that of sulfuric acid that reacted, and it means these moles are in 12.5 because that is the volume that we are related with 25. Therefore we are right to say 12.5 centimeters cubed of sulfuric acid contain 1.25 times 10 power negative 3 moles. What about 1000 centimeters cubed of sulfuric acid? Will contain, cross multiply, and we get the answer as 0.1 molar. Okay, so that is the molarity of sulfuric acid that is obtained. You just play around with volumes. Then the other question wanted us to get the concentration of sulfuric acid in grams per liter. Still, since we want grams, and if it is per liter, then it means that the mass we are going to get must be equivalent to the molarity. So we shall say 1 mole of sulfuric acid weighs, you get the molar weight, which is 98. Then 0.1 molar, 0.1 mole. Where does this one come from? Where does the 0.1 mole come from? It comes from here, the molarity of sulfuric acid. 0.1 mole of sulfuric acid will weigh, we get the mass equivalent to 0.1 mole, and that will be grams per liter, and that is the concentration in grams per liter. Thank you for subscribing. Keep checking for other videos. Thank you.